Hey Sharks, it's Miss Luda here. I promised to help you through your spring break packet, so today's video is going to go over the first two standards, or the same standard. So we're going to go over page 367, 368, page 375 to 376. These two worksheets go over the Pythagorean theorem. Together they are worth 17 points. So let's start with page 367. Your page should look like this, where it's got the stair rail with the right triangle of a height of 5 feet and a base of 12 feet, and it's asking you to fill in these boxes as we go. I'm going to use this interactive lesson to help us through this. If you can follow along with what I'm doing and pay attention to what your worksheet is asking for, then you should be able to solve these questions, these step it out questions 2, 3, and 4, and then I'm going to ask you to do the check your understanding on your own. Let's start. So we've got step it out number 2. Use the Pythagorean theorem to find the length of the set of stairs. Use the equation a squared plus b squared equals c squared in order to solve for the hypotenuse c. Now, if you remember before we left for spring break, we identified that the height is always our a value, the base is always the b value, and the c is always the hypotenuse. I know the hypotenuse is my longest side, and I can identify it because it is across from this 90-degree right angle. So we know it's a right triangle because it's got that little box down there, and that box identifies a 90 degree, but now we're going to prove it by using the Pythagorean theorem. All right, using the equation a squared plus b squared equals c squared, I know a is my height of 5. I know b is my base of 12. So we've got 5 squared plus 12 squared equals c squared. Now I need to solve. 5 squared equals 25. 12 squared equals 144. If I add these together, 25 plus 144 equals 169. So now I have an equation. 169 equals c squared. That was just simply substituting those side lengths, the leg lengths, right? The height and the base, the leg lengths of the right triangle into the equation to solve for c squared. The last step, and I don't forget this step, is you have to find the square root of 169 in order to find the measurement of c all by itself. So we're going to take the square root in order to undo the exponent of 2. The second part of your number 2 tells you take the square root of both sides to solve for c, the hypotenuse. During this interactive lesson, it's given us a couple multiple choice answers. We know that we have to take the square root of 169 to solve for c. Thankfully, 169 is a perfect square. So if you had your perfect square chart, you would have memorized that 169 equals 13 feet. That tells me that the hypotenuse of the right triangle is exactly 13 feet long. Moving on to number 3. We have a right triangle. This triangle is going to teach us something special called the Pythagorean triple. So we have a triangle, a right triangle with a height of 3 and a base of 4. Only certain right triangles have side lengths that are all integers. Remember, integers are whole numbers. These side lengths will not have decimals. They will not include fractions. They are only whole numbers. A set of integers that can form a right triangle is called a Pythagorean triple. So for example, if we had a side length of 5 and 12 with a hypotenuse of 13, these are all whole numbers, these are all integers, so we know this is a Pythagorean triple. Kind of like a grand slam. When you've got all 3 bases of all 3 side lengths being integers, first, second, and third base are whole numbers, then we can call this a Pythagorean triple. If you're a baseball fan, that may make sense. All right, here we are using the a squared plus b squared equals c squared to solve for the hypotenuse. All right, I've got my height is 3. My A value to this triangle is 3. My B value is the base measurement of this triangle, which is 4. This interactive lesson is asking me to drag and drop. If you were to take the FSA this year, this is a good example, drag and drop question. So I've got the height 3 squared plus the base 4 squared. Let's solve. I know 3 squared equals 9 squared. I know 4 squared equals 16 squared. I know if I add 9 plus 16, I get 25. Don't forget, the last step is to always take the square root. Thankfully, 25 is a perfect square, so the square root of 25 is 5. That tells me that the measurement of the hypotenuse is 5. Now, if I have a height of 3, a base of 4, and a hypotenuse of 5, all of my side lengths are integers, and this is a Pythagorean triple. All 3 side lengths are integers. That's my first question I always want to ask. I've got all whole numbers for my measurements, and if I apply the Pythagorean theorem of a squared plus b squared equals c squared, and it's true, then I know it is a Pythagorean triple. Moving on to number 4. Use the Pythagorean theorem to find the unknown side length. So here they're giving us the height of 8 and the hypotenuse of 17, and we have to solve for the base. That means we have to manipulate that a squared plus b squared equals c squared just a little bit to solve for the missing leg length. Here I'm going to substitute the given lengths of the leg and the hypotenuse into that equation, a squared plus b squared equals c squared. I know my height is 8, so I've got 8 squared. I'm solving for my base of b, and I know the hypotenuse is that given measurement of 17. And now I need to simplify, so let's solve. 8 squared equals 64. 17 squared equals 289. For those that didn't know that, let's go to that calculator. We can do 17 times 17 to equal 289, or we can simply do 17, clear that out, sorry, 17 squared. There's my fancy dancy exponent of 2. So 17 squared, 289. So now I need to move my one side length of 64 to the opposite side, to the other side of the equal side, because I'm solving for the base. And in order for me to move 64 from the left side of the equal side to the right side of the equal side, I have to subtract. So I'm going to do C, 289, minus A, 64. So I've got 289 minus 64 equals 225. B squared equals 225, and again, remember, you have to take the square root in order to undo that exponent of 2. Thankfully, 225 is a perfect square, but for those that don't remember, you can type in 225, 225, and take that radical sign. Radical sign with 2. The square root of 225 is 15. So my base is 15 feet. So, would that be a Pythagorean triple? I have a height of 8, I have a base of 15, and I have a hypotenuse of 17. All 3 measurements of that triangle is integers. They are measured in whole numbers. So that is the first question to always ask if it's a Pythagorean triple. Second question, does a squared plus b squared equals c squared make a true statement? Well, yeah, 8 squared plus 15 squared equals 17 squared. As long as that's a true statement, we know it's a right triangle and we have the Pythagorean triple. So in order for you to solve the check your understanding on your own, it's asking you to complete these fill in the blanks. Complete the statement about this triangle. Given the measurement of 12 and the measurement of 9, we need to solve for that missing angle. Since the triangle, we want to ask ourselves, is it or is it not a right triangle? Fill in the blank. Since the triangle is a right triangle or is not a right triangle. And the what lengths? What lengths are 9 and 12? There's a vocabulary word we were using to identify the height and the base. What word is that? What are the measurements of 9 and 12? And then finally, if you do a squared plus b squared equals c squared, what is the missing measurement of the hypotenuse? For number 2, A and B, it's asking you to use the sailboat, the measurement of the sailboat for your a squared plus b squared equals c squared equation. I think the equation on your worksheet is a little bit different from the one that's on my computer screen right now. You should have a height of 12 and a hypotenuse of 13. And it's asking yourself to find the missing side length of the base B. After you find that missing side length, ask yourself, is it a Pythagorean triple? I'm going to continue over to, I'm not, just joking. I'm going to pause this video and then I'll start again for page 375. All right, so this concludes 367 and 368, and I'm going to do another video for 375 to 376. See you in a moment.